Hello everyone, welcome to the next lecture of the placement series. So in this lecture, we'll study about the operators that are used in Java programming language. So operators are the symbols that are used to perform a specific operation on the operand. The operators in Java are unary operators, arithmetic operators, relational operators, logical operators, bitwise operators, ternary operator, and assignment operator. We'll study each of them one by one. So let's first start with the unary operator. Unary operators are those operators which take only one operand. In unary operators, we have increment operator, decrement operator, minus operator, logical not operator, and bitwise not operator. So let's first start with the increment operator. So increment operator is denoted by plus plus sign. So what does it do is, it increases the value of a variable by 1. So basically it adds 1 to the value of the variable. So it can be used in two different ways, prefix and postfix. So in case of prefix, I write operator first and then the name of the variable. So it is denoted as plus plus then variable name. Whereas in case of postfix, I write it as variable name then plus plus sign. So it is written as variable plus plus. So let's see an example. I have a variable a which is given the value 7. If I am writing plus plus a, the value of a in this line will be 8. So in next line I am writing a plus plus. So again it will add value of 1 to the variable a. So the value of a will be 9. So now let us see what is the difference in the usage of prefix and postfix operator. So if I am writing system.out.println a plus plus. So in this case, there are two things to be done. First, I want to print the value of a, and second, I want to increment the value of a. So in these cases, when I have to do two particular operations in a single statement, then there is a difference between prefix and postfix. Now, postfix means I'll have to do the increment afterwards. So this can be broken down into two steps. In the first step, I'll print the value of a, that is the current value of a will be printed on the screen. Then a will be incremented by 1. So now in this statement, we are writing system.out.println. So in last lecture, we saw system.out.print. So what is the difference between print and println? So in case of print, whatever is written inside the print function, it is displayed on screen. Whereas in case of println, whatever is written inside the println statement, it is printed on screen. And at the end, it appends a new line character. So basically, it is equivalent to print statement plus an enter at the end. So in the next statement, I have system.out.println plus plus a. So again, I have to do two particular operations in this line. I want to increment value of a and I want to print the value of a on screen. But here I am using prefix operator. So I'll increment the value of a first. So this can be broken down into two steps. First, I'll increment the value of a and then I'll print the new value of a on the screen. So let's see another example where there is a difference between the usage of prefix and postfix operator. So let us say I have b is equals to a plus plus. Again in this example, I am doing two particular operations. First, I am assigning the value to another variable. Second, I am incrementing the value. So now the order in which these two operations are done depends whether I am using prefix operator or I am using postfix operator. So if I am using b is equals to a plus plus, so in this case, I am using postfix operator. So first I'll assign the value of a to b. The current value of a will be assigned to b and afterwards a will be incremented. Whereas in second case where I have b is equals to plus plus a, because there is a prefix operator, so first I'll increment the value of a and then I'll assign the new value of a to b. So now let's see the decrement operator. It's exactly same as the increment operator. The only difference is it decreases the value by 1. So let's see an example. Here I am saying if a is equals to 7. So if I am doing minus minus a, I'll decrease the value of a. So after this line, the value of a will become 6. Next I have a minus minus. Again the value of a will be decremented by 1. So after this line, the value of a will be 5. So let's see the examples where there is a difference in usage of prefix and postfix operator. So let's see the difference in these two examples. I have system.out.println a minus minus and system.out.println minus minus a. So in first case, I have postfix operator. So first the value of A will be printed on the screen and then A will be decremented. Whereas in the case I am writing system.out.println minus minus A, here I am using prefix operator. So first I'll decrement the value of A and then I'll print the new value of A on the screen. So let's see the next example. I have B is equals to A minus minus and B is equals to minus minus A. So in these examples also, in the first case where B is equals to A minus minus, we are using postfix operator. So first the value of A will be assigned to B and afterwards the value of A will be decremented. Whereas in the second case where I have B is equals to minus minus A, it's a prefix operator. So first I'll decrement the value of A and then I'll assign the new value of A to B. So let us see a code where I'm using these increment and decrement operators. So first I'm declaring three variables A, B and C. A is given value 10. So I have a variable A which is given value 10. So in next line I have B is equals to A minus minus. So now this is a postfix operator. So first I'll assign the value of A to B and then I'll decrement A. So after this line I'll have B is equals to 10 and then A will become 9. So let's see the next line. It is C is equals to plus plus B. So this is a prefix operator. So first I'll increment the value of B and then I'll assign the new value of B to C. So after this line I'll have B is equals to 11 and then C is given the value of B, that is 11. So the next line I'm printing A minus minus. So A minus minus, I want to print this. So this is a postfix operator. So first I'll print the value of A. So what is the value of A? 9. So 9 will be printed on the screen and then A minus minus. So afterwards value of A will be decremented. So after this line A becomes 8. So in next line I'm printing system.out.println plus plus B. So this is prefix operator. So first I'll increment the value of B and then I'll print it. So the B value is 11. So first I'll increment the value of B. So B will become 12. Then I'll print 12 on the output screen. Next I have system.out.println minus minus C. Again this is a prefix operator. So first the value of C will be decremented and then the new value of C will be printed on screen. So what is the value of C? C is 11. So first I'll change C to 10. So now this new value is printed on screen. So I'll get the output as 9, 12 and 10. So next is the unary minus operator. It represents the negative value. So let's see an example where I have int A is equals to 5. Then I have int B is equals to minus A. So the value of B is minus 5. In the next line I have int C is equals to minus 7. So this denotes the negative value 7. So here I am taking just one operand. So minus 7, I have a single operand. So this is a unary operator. So if I write int A is equals to 5 or I write int A is equals to plus 5, both of them mean the same. So we do not use unary plus because by default the number is considered to be positive. So next we have logical NOT and bitwise NOT operator as unary operators. So we'll study each of them in logical and bitwise operators respectively. So next we have arithmetic operators. So these are binary operators. That means they'll use two operands to perform a specific operation. So we have addition, subtraction, multiplication, division and modulus in arithmetic operators. So what does addition do? It performs sum of two numbers. Subtraction, it gives the difference between the two numbers. Multiplication, it gives the product of two numbers. Then we have division. When I divide two numbers, it gives me the quotient of these two numbers. Then I have modulo. It returns the remainder on dividing the two numbers. So let us see an example to understand the usage of arithmetic. So here I am given two variables A and B. The value of A is 17. And the value of B is 4, right? So in the first statement I have sum is equals to A plus B. So what is the value of A plus B? I'll get 21. So the output in this case will be sum is equals to 21. Next I have difference is equals to A minus B. So what will I get when I do A minus B? So 17 minus 4 I'll get 13. So the output will be difference is equals to 13. In the next line I have product is equals to A multiplied by B. So when I multiply 17 and 4, I'll get 68. So the output will be product is equals to 68. Next statement is quotient is equals to A divided by B. So when I divide 17 by 4, I'll get quotient as 4. So when I divide these two numbers, 17 becomes the dividend. So 4 becomes the divisor. So 4 4s are 16. So this is the quotient. So when I divide two numbers, this is the quotient. So I'll get 17 divided by 4. Quotient is equals to 4. So in the next statement I have remainder is equals to A mod B. So when I divide them, the remainder is 1. So I'll get remainder is equals to 1. Suppose I have two integers, A is equals to 9 and B is equals to 2. When I do A divided by B, both of them are integers, so I'll get integer output. Now A becomes the dividend, B becomes the divisor. So if I divide 9 by 2, I'll get 4 as quotient and 1 as remainder. That is, if I do A divided by B, I will get 4, and if I do A mod B, I'll get 1. Now what if I want to get the complete answer here, that is 4.5. Both of them are integers, so I'll only get integer output. So if I store the answer in a float variable. So if I do float C is equals to A divided by B. Now again both are integers, so 9 divided by 2 becomes 4. So this 4 is typecasted into float using widening typecasting. So this 4 becomes 4.0, but I will not get 4.5. If I want to get floating point as output, I'll either have to make one of them as floating point number or both of them. So what I can do is, either I can write 9.0 divided by 2. In this case, 9 becomes the floating point number. Or I can write 9 divided by 2.0. Or I can convert both of them. That is 9.0 divided by 2.0. Also, I can typecast one of them to floating point number using manual typecasting. So I can say float 9 divided by 2. So now this 9 becomes 9.0. I can also typecast 2 and I can also typecast both of them. So now this will give me 4.5. That is the floating point number as output. Next we have relational operators. So relational operators are used for comparison. They compare two values and return a Boolean output. So first we have is equal to operator. So what this checks is, if two values are equal, it will return true. Otherwise it returns false. Then we have not equal to. It checks if both these values are not equal. In that case it returns true. Otherwise it returns false. Next we have greater than. If the first value is greater than the second value, it returns true. If I have A greater than B, it will return true if this value is greater than the second value. Next I have less than. So A less than B, it will be true if the value of A is less than the value of B. Next I have greater than equal to. So A greater than equal to B means this will return true either A is greater than B or A is equal to B. Then we have less than equal to. So if I say A less than equal to B, this will return true if either A is less than B or A is equal to B. So now let us see an example. In this case I have two numbers, A is equals to 17 and B is equals to 4. So now first I want to check if A is equals to B. Now A and B are not equal, so double equal to will check for equality, so it will return false in this case. So output of this first line will be false. Next I have A not equal to B. So here A is not equal to B, so not equal to operator will return true in this case. Next I have A greater than B. So 17 is greater than 4, so this will return true. Next I have A less than B. So 17 is not less than 4, so less than operator will return false. Next I have A greater than equal to B. So here I want to check if 17 is greater than or equal to 4. So since 17 is greater than 4, this will return true. Next I want to check if A is less than equal to B. So 17 is not less, and 17 is not equal to 4. So both the conditions are false, so this will return false. Next we have logical operators. So we have three types of logical operators: logical AND, logical OR and logical NOT. So logical AND is represented by double ampersand sign, logical OR is represented by double vertical bar sign, and logical NOT is represented by exclamation sign. Now we'll see each of them in detail. So first we have logical AND operator. It takes two expressions and performs the AND operation on them. So we have a truth table of the AND operator. So if both the expressions are true, only in that case AND returns true. If one of the expression is false, the output of AND operation is false. Next we have logical OR operator. It takes two expressions and performs the OR operation. So you can see in the truth table, if either of the expression is true, OR operator returns true. If both the expressions are false, only in that case logical OR operator returns false. So next we have logical NOT operator. It takes only one expression as input. That's why it is also a unary operator. So how does it function is, if I pass a true value to logical NOT, it will return false, and if I pass false value to logical NOT, it will return true. So it complements the original expression. So now let us see an example which uses logical operators. So here we have three variables A, B and C. Variable A is given value 10, variable B is given value 20 and variable C is given value 30. So now in the first expression we are checking if A is less than B and B is greater than C. So this first expression A is less than B. So 10 is less than 20. This is true. And the second expression B is greater than C. So 20 is greater than 30 will return false. So as we have seen in AND operator, if any one of the input is false, it returns false. So for this output is false. So let's see the second. We have A greater than equal to B or B less than equal to C. So now A greater than equal to B. A is neither greater than B nor equal to B. So this expression will return false. Or B is less than equal to C. B is less than C. So this expression will return true. False or true, or will return true in this case. So I'll have true as output. So next I have is A less than B and I have not of this. So A is less than B, this is true. So if I do not, so I'll get false. So the output of this program will be false, true and false. Clear? Next we'll see short circuiting. If I have a logical expression and its evaluation stops before the complete execution, then it is known as short circuiting. So why does short circuiting happens? It happens because the result is clear even before the complete execution of the expression. So there are two types of short circuiting in Java. So first type of short circuiting happens with logical AND operator. So let us say I have multiple conditions and they are connected with the help of AND operator. So now I know if one of the condition is false, the result will be false. So I need not evaluate the complete expression. I stop as and when I find that one logical expression is false, because if I AND any expression with false, I'll get output as false. So my execution stops in between. Second type of short circuiting happens with logical OR operator. So if I have multiple expressions which are connected with logical OR operator, and if one of the expression returns true, I need not check the subsequent expressions, because if one of the expression is true and if I OR true with any other logical expression, I'll get the output as true. So I am clear with the result even before the expression is completely evaluated. So in this case, I exit the evaluation of this logical expression. So this is also known as short circuiting. So short circuiting is done to avoid the unnecessary work. Next we'll see bitwise operators. So these are the operators which perform functions on individual bits of a number. So if I have a decimal number and I want to do bitwise operation on that, first the decimal number is converted to a binary number to get the bits, then the bitwise operation is performed on those bits. So we have 6 types of bitwise operators. First we have bitwise AND. It is denoted by single ampersand sign. Next I have bitwise OR. It is denoted by a single vertical bar sign. Next I have bitwise XOR. It is denoted by caret sign. Next I have bitwise NOT. It is denoted by tilde sign. Next I have left shift. It is denoted by 2 less than signs. And last I have right shift. It is denoted by 2 greater than sign. So we'll see each of them. First we have bitwise AND operator. So it is similar to logical AND operator. Just the difference is, instead of working on the expression, it works on individual bits. So now if any one of the bit is 0, bitwise AND returns 0. Next we have bitwise OR. It is similar to logical OR. Now if any one of the bit is 1, logical OR returns 1. Next we have XOR. How does bitwise XOR function? So this is the truth table of bitwise XOR. If both the bits are same, bitwise XOR returns 0. If the bits are different, bitwise XOR returns 1. Next we have bitwise NOT. This takes one bit as input. That's why it is also a unary operator. So it complements the input bit. If the input bit is 0, it returns 1. If the input bit is 1, it returns 0. So now let us see an example involving bitwise operators. So here I have 2 integer variables. A has value 60 and B has value 13. So now if I do A and B, I first have to convert A and B to binary and then I'll apply bitwise AND on that. So if I write 60 in binary, I can write it as 0011 1100. So if I write 13 in binary, I can write it as right. So now if I do bitwise AND, here I have 0 and 1. So one of them is 0, so I'll get 0. 0 and 0, both are 0, so I'll get 0. 1 and 1, here I'll get 1. Here also both are 1, so I'll get 1. 1 and 0, I'll get 0. 1 and 0, 0. 0 and 0 is 0. 0 and 0 is 0. So finally this is the result of AND operation and the value here is 12. Right. Next I have to do A or B. So 0 or 1, so one of the input is 1, so I'll get 1. 0 or 0, both are 0, so I'll get 0. 1 or 1, I'll get 1 here. 1 or 1, again 1. 1 or 0, so one of the input is 1, or will return 1. 1 or 0, 1. Both are 0, 0 and 0. So this in decimal numbers will give me 61. So next I want to do A XOR B. So now if I XOR both of them, 0 XOR 1, both are different bits, so I'll get 1. 0 XOR 0, both are same, so I'll get 0. 1 XOR 1, they are same, so I'll get 0. 1 XOR 1, again same bits, I'll get 0. 1 XOR 0, so these are different bits, I'll get 1. Again the bits are different, I'll get 1. Same bits, I'll get 0 and 0. So this will give me 49. Next I want to do complement of A. So I'll just take A and invert the bits. So for 0 I'll get 1. For 0 I'll again get 1. 1 I'll get 0. 1 I'll get 0. 1 I'll get 0. Again 1 I'll again get 0. For 0 I'll get 1. And for 0 I'll get 1. So this in 2's complement represents minus 61. So the output of this program will be 12, 61, 49 and minus 61. So now the next bitwise operator we'll see is left shift operator. It shifts all the bits to the left and inserts zeros at the right end. So let us understand this operator with the help of an example. So let us take an integer variable A which is equal to 6. So I can write 6 in binary like this. So now if I want to shift the bits to left by 1 bit, so I'll write A left shift 1. So this will shift all bits one position to the left and the leftmost bit will be discarded. On the right hand side, it will insert 0. So if I do this, I'll get 12 as output. So now let's take an example. If I left shift A by 2. So all the bits will be shifted 2 positions to the left. The 2 leftmost bits will be lost and 2 zeros will be inserted at the right end. So this becomes the binary equivalent of 24. So now if I do A left shift 3. Now this means I'm shifting all the bits 3 positions to the left. So now 3 leftmost bits will be lost and 3 zeros will be inserted at the right end. So this will give me 48. So as you can see in left shift operator, every time I shift all the bits 1 position left, I multiply it by 2. So basically if I have a number n, I left shift it by k bits, this is equivalent to n multiplied by 2 raised to the power k. So this expression is only true if all the lost bits are 0. Next we'll see right shift operator. It shifts all the bits to the right. So now let us understand this with the help of an example. A is equals to 10. So I can write it in binary like this. So now if I shift it to 1 position right. So I can write A right shift 1. So this will shift all bits 1 position to the right. So the rightmost bit will be lost and 1 0 will be inserted at the left end. So this is binary equivalent of 5. So now if I do A right shift 2, this will shift all the bits 2 position to the right. The 2 rightmost bits will be lost and 2 zeros will be inserted at the left end. So this will give me 2. Now if I right shift it by 3. In this case, all the bits will be shifted 3 positions to the right. The rightmost 3 bits will be lost and 3 zeros will be inserted at the left end. So this will give 1 as output. So now you can see if I right shift n by k positions, this is equivalent to n divided by 2 raised to power k. Every time I right shift a number by 1, I divide it by 2. So if n is right shifted k times, it will be divided by 2k times. So if I divide n by 2k times, I will get n divided by 2 raised to power k. And I will get the floor value of this. So if I have 10, I will get 5. I will not get 5.5. So I will get the floor value. So in this case, this formula doesn't depend on the lost bits. So irrespective of the lost bits, this formula holds. Next I have ternary operator. It is the only operator that takes 3 operands. It is used as a one-line replacement of if-else statement. So it takes 3 operands. What are these 3 operands? First I have is a condition. Then there is a question mark. So I check this condition. Based on this condition, I can either move to expression 1 or expression 2. So in between the 2 expressions, I have a colon symbol. So if this condition is true, I execute expression 1. If this condition is false, I execute expression 2. So let us see an example of the ternary operator. So let us say I have a variable x equal to 5. So now if I do y is equals to x greater than 2 question mark 4 colon 6. Now this is the condition. This is expression 1. This is expression 2. So now I'll first check this condition. So x greater than 2. I have x equal to 5. So this condition is true. So if this is true, I'll execute expression 1 because this is true. So now I'll get 4 on the right hand side. I am assigning this to the value of y. So y will get value 4 here. Right? So let's see another example. If I have z is equals to y greater than x question mark 2 colon 3. So now first I'll evaluate this condition. So y is 4, x is 5. So 4 greater than 5. This returns false. So the condition is false. So I'll go to expression 2. So the right hand side returns 3 and I'll assign this value 3 to z. So I'll get z as 3. So let us see another example. So in this example, I am given marks equals to 75. I'll first check the condition if marks is greater than 40. So this condition is true. So I'll move to expression 1. So expression 1 has a string pass. So now this pass string is stored in the string result. So the string result will now contain the value pass. So it is a replacement of if-else statement where I can write if marks greater than 40, then result is equals to pass, and else the result is equals to fail. The next type of operators are assignment operators. So these operators are used to assign value to a variable. So in the left hand side of the assignment operator, I have a variable, and on the right hand side I have a value. So in this case, the value at the right hand side is assigned to the variable at the left hand side. So we have two types of assignment operator. First I have a simple assignment operator, that is denoted by equal to sign. Then I have a compound assignment operator. So let us first see what is simple assignment operator. The simple assignment operator consists of an equal to sign. It assigns the value at the right hand side to the variable at left hand side. The value at the right hand side must be of the same data type as the variable on the left hand side, otherwise it will give an error. So let's see an example of this. Int number is equals to 7. So inside the variable num, I'll store the value 7. Then I have character ch equals to v. So now this v character is stored in the character variable ch. Then I have double variable d, which is given value 2.5. So 2.5 is a double value which is stored in a double variable d. And last I have string str is equals to victory point. So victory point is a string which is stored in a variable str which is of string data type. Next we will see compound assignment operator. So in this assignment operator, I have an operator like plus, minus, multiply, divide along with the equal to operator. So now what is the meaning of the statement num plus is equals to 5? It means I'll add 5 to the num variable and I'll again store it in the num variable. So this is equivalent to saying num is equals to num plus 5. So if I write a multiply is equals to 2. So this means a multiply by 2 and I'll store this back in variable a. So this is equivalent to saying a is equals to a multiply by 2. Next I have x minus is equals to 10. So this means x is equals to x minus 10. Next I have y and is equals to 10. So this means I'll bitwise and y and 10 and store the result back in y. So this is equivalent to saying y is equals to y and 10. In Java, I can have all these as compound assignment operators. So with equal to sign, I can use plus, minus, multiply, divide, modulo. That is all the arithmetic operators along with left shift, right shift and or and XOR. So these 5 bitwise operators and all the arithmetic operators can be used along with the equal to sign for the compound assignment operators. So now let us see an example. Here I have two integer variables a and b. So a is given the value 15 and b is given the value 20. So first I have a plus is equals to 5. So I'll add 5 in a and I'll store back in a. So a will become 20, right? Next I have b multiply is equals to 2. So I'll multiply b by 2 and store it back in b. So b will become 40. So the output in this line will be a space b, that is 20 space 40. Next I'll do b divide is equals to a. So this means I'll divide b by a and store it back in b. A will not change. So if I divide 40 by 20, I'll get 2 and 2 is stored back in b because this is equivalent to b is equals to b divided by a. So if I do b divided by a, I'll get 2 and b is equals to 2, but a will not change in this expression, so a will be 20, right? So in this case, the output will be 20 space 2. So let's see the next. Next I have a XOR is equals to 6. So this means I'll XOR a with 6 and store it back in a. So a is 20. So for doing this bitwise operator, first I'll have to convert a to a binary number. So I can write 20 in binary as 0001 0100 and I have to XOR it with 6. So So how will I write 6 here in binary? 1, 1 and 0. So I'll have to do XOR of these two numbers. Now 0, 0 both are same. So XOR will be 0. 1, 0 these are different bits. So XOR will be 1. 1 and 1 I'll get 0. 0 and 0 I'll get 0. 1 and 0 these are different bits. I'll get 1. 0, 0 I'll get 0. Again 0 and 0. So this will return me 18. So now A becomes 18, B is still 2. So the output of this line will be 18 space 2. So let us move on to practice some MCQs based on these operators. So now let us see the first question. In the first question, we are given a byte variable A whose value is 126. So the value of A is 126. Now we are doing A++. So A++ increments the value of A. So from 126, A will become 127. Right? Now again we are given A++. Now A++ will again increment the value of A. So from 127, A should become 128. Now can A become 128? No. Because as we have seen in the last class, range of byte data type is from -128 to 127. So the value of A cannot be more than 127. So what happens here is, when I try to increment the value from 127, it goes in cyclic way and the value again becomes -128. So from 127, it will become -128. So the value of A in first print statement will be -128, right? Now again I am doing A++. So when I am adding 1 to -128, what will I get? I'll get -127. So now in the print statement, what will be the value of A? The value of A will be -127. So what will be the output? So the first value is -128, the next value is -127. So now moving on to the next question. In this question, I am given an integer variable x whose value is 20. Right? In next line, I am given a ternary operator. So how does ternary operator evaluate? First, we check the condition. So the condition is x less than 15. What's the value of x? It's 20. So 20 less than 15 is false. So we'll move on to the expression 2. Now in expression 2, again we are given a ternary operator. So this is an example of nested ternary operator. That means I have a ternary operator inside another ternary operator. So now in the second expression, again I have a ternary operator. So what is the condition for that? The condition now is x less than 22. So again I'll first check the condition. So x less than 22, x is 20, so 20 less than 22. Now the condition is true. So inside the second expression, I'll move on to the first expression because the condition is true here. So what's the first expression? It is medium. So in the left hand side, I'll assign this string to answer. So the answer will be medium. So what will be the output of this question? It will be medium. Okay. So now let's see the next question. In this question, we have binary operators. So how do binary operators work? First, we convert a decimal number to its binary equivalent and then we perform the operation on the individual bits. So here I have x equals to 11 bitwise and 9. So first we'll write 11 in binary. So how will we write 11? We'll write it as 1011. How will we write 9? We'll write it as 1001. If I apply AND to it, so 1 and 1 will become 1. The result of AND operation is 1 when both the bits are 1, right? So here only one of the bit is 1, so I'll get 0. Here no bit is 1, so I'll get 0. Here both the bits are 1, so I'll get 1. So the result of this operation is 9. So this is the value of x. So x will be equal to 9 here, right? In the next expression I have y equal to x XOR 3. So what is the value of x? It is 9. So how will I write 9? I'll write it as 1001. How will I write 3? I'll write it as 0011. Now I have to apply XOR operator. So how does XOR work? When both the bits are same, it gives 0. When the bits are different, it gives 1. So here both the bits are same, so I'll get a 0 here. Bits are different, I'll get 1. Again bits are same, I'll get 0. Now the bits are different, so I'll get 1. So what is this value? This is 10. So now this is the value of y. Now in print statement I have y or 12. So we'll do this operation, y or 12. So now what is the binary equivalent of y? That is 10, that is 10, 10. So what is the binary equivalent of 12? It is 1100. And now I have to apply the OR operator. So how does OR function? If one of the bit is 1, it gives 1. If both the bits are 0, it will give 0. So now here both the bits are 0, so I'll get 0. Here one of them is 1, I'll get 1. Here also one of them is 1, I'll get 1. Both are 1, I'll again get 1. So now what is this value? So now this is equivalent to 14. So what will be the output? It will be 14. Moving on to the next question. Which of the following is not a logical operator? So the first operator, it is 2 ampersand sign represents logical AND operator. Next we have logical NOT operator. C option we have 2 pipe operator. So that is logical OR. In the last option I have a single pipe. This is bitwise OR operator. So it is not a logical operator. So D is the answer. So let's see the next question. So we have to give the output of this code. So in this code I have integer variable A and integer variable B whose value is 20. Right? Now the value of A is 90 divided by B. So 90 divided by 20. Now this is an integer, this is an integer. So this will do integer division. So the value of A will be 4. What will be the output in this case? 4 will be printed. So let's see the next question. So in this question I have an integer variable A whose value is 10. So next I have 2 more integers B and C. In the next line I have B is equals to A plus plus. So now this is increment operator and it is used in postfix manner. So I can break this statement into 2 steps. First is I'll assign the current value of A to B and then I'll increment A. So in this step the current value of A will be given to B. So B will become 10 and now A will be incremented, so A will become 11. Right? In the next line I am given C is equals to A. So now the current value of A will be given to C. So now what is the value of A? It is 11. So C will become 11. So in the next line I am just printing the value of A, B and C without any space. So the output will be 1, 1, 1, 0, 1, 1. So that is A option. So now let's see the next question. So here I have 2 integer variables C1 and C2. Next I have an integer variable A. And what's the value of A? A's value is minus 8. So A is equal to minus 8. Next I have B whose value is 3. Now C1 is given the value minus A plus B. So now this minus A is prefix operator. So first the value of A will be changed and then it will be used in this expression. So now first A will become minus 8 minus 1. So the value of A will be minus 9. Now I'll use this A in this expression. So C1 will be equal to minus 9 plus 3. So this is minus 6. So the value of C1 is minus 6. Right? So in next expression C2, I have A minus minus plus B. So now this is postfix operator. So first I'll use the current value of A in this expression and then I'll decrement A. So the current value of A is minus 9. So I'll use it here minus 9 plus 3. So now A will be changed to minus 9 minus 1, that is minus 10. The value of C2 will be minus 9 plus 3. So that is minus 6. So C1 will be minus 6 and C2 will be minus 6. So the correct option is D. So let us see the next question. Here I have 4 variables I, J, K and M. So what is the value of I? It is 0. The value of J is 1. The value of K is 2. Right? And next we have M. So what is the value of M? It is I plus plus. This is logical OR. J plus plus. logical or K++, right? So all these three are increment operators and they are used in postfix manner. So what does that mean? I'll increment them after this expression is evaluated, right? So here I'll use the current value of I. So what is the current value of I? It is 0. So in this expression I'll use 0, and after this expression I'll increment I to, from 0 it will become 1, right? Or, so I'll use the current value of j. So current value of j is 1. So here 0 means false, so false or true. Now the OR expression becomes true. As we have seen in short circuiting, whenever we know the answer, now it is true. So if I do true or anything else, I'll get the answer true only. So due to short circuiting, this unnecessary work is eliminated and M is directly assigned the value 1 here. This expression doesn't execute. Now after this j is used, I'll increment j to, from 1 it will become j is equals to 2. But now K++ hasn't executed, so the K value will remain same, it will be 2 only. Now I'm printing the value of M, I, J and K. So M here is 1, I is 1, J is 2, K is also 2. K is not incremented because this expression is not being executed due to short circuiting. Clear? So let's see the next question. So which of the following is the correct expression that evaluates to true if the number x is between 1 and 100 or the number is negative? So x should follow either of these two conditions. In that case it should be true. So it has to follow either the first condition that it should be between 1 and 100 or the second condition that it should be negative. So I have to put an OR symbol between the two conditions. Now what is the second condition? The second condition is very simple. It is just the number should be negative. So the number should be negative means it should be less than 0. So the second condition is simply x less than 0. What is the first condition? It should be between 1 and 100. So that means it should be greater than 1 but less than 100. So between 1 to 100 means it should be from 2 to 99. So it should be x greater than 1 and at the same time it should be less than 100. So both these conditions should hold simultaneously. That's why I have put the AND symbol between them. So this is the first condition when x is between 1 and 100 or x should be negative. So in either of these two conditions, the expression should be true. So this is the correct expression. So why the first expression here is wrong? In first expression it is written 1 less than x less than 100. Now this is a logical operator. So if x is between 1 to 100, it will be definitely greater than 1. It will become true. This is Boolean and this is integer. So in logical operator, I cannot use different data types. I am using Boolean as well as an integer for this logical operator. So these data types are not allowed in case of Boolean operator. So this expression will give an error. So the second expression is true. So in third expression, I am having an AND operator between these two conditions. So this is saying that the number should be between 1 to 100 and it should be negative. So this condition is not true. Similarly, in the last condition also, I am using 1 greater than x greater than 100. So this will evaluate to a Boolean data type and this is integer. So it will give an error. So the correct option is B. So thanks a lot for watching. We'll meet in the next lecture.